Hello Willow class. Today we are going to take a closer look at the algebraic expressions that we were substituting into. So we're going to look at different ways to represent them with objects and with pictorial representations. So what I'm going to do is do this video in stages, and then I will suggest that you pause it whilst you have a go at sections from today's worksheet. So make sure you have today's worksheet printed out and ready to go. Okay, the first thing we're going to be looking at is how we could represent them with some objects. So we're going to use these multi-link cubes to be an unknown amount. So we don't know how much this is worth. So because we're working in algebra, we can give that a letter. So let's call that one X. We're going to use these counters to represent numbers that we do know. So each of these is simply worth 1. So looking at what we've got here represented on my table, we could say that this is X. These are each worth 1. So the expression for what we've got here on the table is X add 3. Okay, so we've got the unknown value here. That's our X. And then we've got our 3 counters. So that is the add 3. So this represents X add 3. Let's have a go at another one. So if I add on here. Okay. So you can see we have, again, remember that this is the unknown amount. So we've got 3 lots of the unknown amount. And we called it X before. Let's stick with that for now. So we've got X, X and X. Remembering that we don't need to use that multiplication symbol because in algebra that's the default. So we could say those 3 are 3X. And then we've got just 2 of these counters, remembering that these counters are just represent 1 each. So we've got 2 of those. So what you can see on the table here is 3x, x, x and x added to the 2. Okay, what would this one be? Did you get 4x plus 4? Excellent. Okay, so let's have a little look. What if I put those 2 there, and this one, and we had another 3 of these, and then 2 here. So we've got x and x, so 2x, add 1, add 3x, add 2. So let's write that one down. We've got 2x plus 1 plus 3x plus 2. It's a little bit clumsy though, isn't it? Because we've got x's here and x's here. So we just rearrange it. We can simplify it just as we would simplify our fractions. We've now got the same amount, but we can add our 3x and our 2x. So we've simply got 5x plus the 3 there. So 5x plus 3. So whichever order they're presented in, x is still worth x if it's here, or if it's over here, or if it's in the middle here. What about this one then? How would you write this one? Okay. Have a think. So an x here, 2x here. In total, we should have 3x. 1, 2, 3, 4, 1 more, 3x plus 5. Okay, if you pause the video at this point, have a go on your worksheet at question 1, and there's A through to H. Okay, you can mark those ones before you go on to the next section if you like, or wait until the end and mark them all and then go back and have a look. So the next thing we're going to look at is function machines. Now, a function machine is just a way of writing down what happens to a number that shows how it changes. So I'll draw a function machine for you. So the input of the function machine is the number that goes in, and you probably guessed the output is what comes out. So if I put the number 2 into my function machine, something happens to it and it comes out as a different number. So it might come in at 2 and go out as 5. So you may already have started to think about what has happened to the 2 to turn it into 5. Let's see if you're right and see if it works for this one. So if you put a 5 in, an 8 would come out. And they've both gone into the same function machine. So whatever happened to the 2 to make the 5 is what happened to the 5 to make the 8. Okay. 2 add 3 makes 5, and 5 add 3 makes 8. So this function machine is an add 3 function machine. Let's try another one. See if you can work out what goes in that middle box. What does this function machine do? So for this one, we have 7 going in and 21 coming out. So you may have worked out or have an idea what happened there. The numbers got bigger. So it's either going to be an add or a multiply. Which do you think it is? See if you're right. If I put a 5 in, a 15 comes out. So, yeah, it has to be a multiply by 3 function machine. Now, we can then use this function machine with our algebra. So if we said that y went in as the input, and we know that the function machine multiplies by 3, we don't know how much that y is worth yet. That's our mystery number. So how would we write the output there? Went in as y. We knew it was multiplied by 3. Remember the rule? We don't need to use that multiplication symbol. But 3 lots of y came out. The y was multiplied by 3, turned into 3y. Okay, give you one more, and then you can have a go at some on your sheet. So for this function machine, we're going to start with 6. We're going to start with 11, and we're going to start with a. Okay, so each of these numbers goes in and out the other side, and this one goes a 3. So you can see the numbers got smaller. Could it be 6 subtract 3 to give us the 3? Or maybe it's 6 divided by 2 to give us 3. Let's see. You should be able to work it out from this next one. 11 goes in, 5.5 comes out. So if it had been minus 3, we wouldn't have 5.5. So this function machine must be dividing by 2. So we've got a, and it's divided by 2. What comes out here must be a divided by 2. There's 2 ways we can write this. The first one you might think of is a divided by 2 like that. But if you remember what we talked about yesterday, said it is more usual with algebra to write it in a fraction form. So a divided by 2, like that. Both are correct, but this is the more standard way of writing it. So if you want to pause the video there and have a go at question 4, which starts on the first page and continues on to the second page. Hello. Okay, going on to the next stage where we're looking at how we might describe in words what an algebraic expression means. So I'm going to give you the expression written in algebra and written in words, and you've got to match up the pairs, and then there's some to have a go at on the sheet. So let's pop them up onto the board over here. So let's take the expression. I'll use the letter Y for the unknown in this one. So Y divided by 7 is going to be one of them. Y multiplied by 7. 7 less than Y. 7 more than Y. Y multiplied by Y, and the last one is Y less than 7. Shocking handwriting, apologies, Willow. Okay, so that's the expressions in words, but if they were written as an algebraic expression, which would be? So which would be Y squared? Which would be 7Y? Which would be 7 take away Y? Which would be Y divided by 7? Which would be this one? And the other one I've missed is this one. Let's see if you can match those up. So, can you see which one it matches to? Y divided by 7 is in that fraction form, Y divided by 7. Of course, you might see it like that, but this is the more common format. How about Y multiplied by 7? Remember that default, you don't need that multiplication symbol. So where we've got a Y and a 7 together, straight across, there it is. 7 less than Y. Okay, so is it this one with the subtraction or this one? So 7 less than Y. This is 7, take the Y, and this is the Y, take the 7. We need this one. 7 more than Y. That's the addition. 7, Y multiplied by Y. So Y multiplied by itself. Remember, that's what we mean by squared, isn't it? Y multiplied by Y. And we've got left 7 take Y. Let's see. Y less than 7. Yeah, so they've got the 7, but you've taken the Y from it. So this one in here. You should now be able to match up all the pairs in number 5. So pause the video, have a go at number 5, and then we'll be back to look at pictorial representations in just a minute. I hope you paused, but now you're back again. So we're now going to look at 2 different pictorial ways that an expression can be shown. So one is looking at 2D shapes, where you can work out their perimeter, and the second is looking at a bar model. Okay, and then there's questions on the sheets, questions 6 and 7, which is similar to this that you can have a go out on your own. So, firstly, let's look at the idea of using algebraic expressions to represent explain our perimeter. So here we have a triangle, 3 different length sides. We've got a scalene there. So let's call this one, we don't know how long it is, so we'll call it A because it's unknown. The longest side, B, and this one, C. So if we wanted to describe the perimeter of that, we can't add up any numbers, but we can add up these unknowns. So we could simply put A plus B plus C. Did you get that? What about a rectangle? Obviously perfectly drawn. Got 2 sides the same length, so I just label one of them. Let's call that one A. These 2 that are parallel, also the same length, so I just label one B. How would you write that as an algebraic expression? The perimeter of the whole rectangle. So we'd need starting here, along here, here, and here. So A and B and A and B. Got those two A's and two lots of B. Rather than writing A plus B plus B, we can write it in this shortened way. Let's take a kite. So there's our line of symmetry down the middle. So we've got these two lengths the same, and these two the same. So what would be the way of writing the perimeter of our kite as an algebraic expression? We've got this A and A, B and B. Did you get it? Hope so. Interesting, isn't it? That you've got the same algebraic expression for the two different shapes, because of course the A here represents this side, but the A here represents a different length. A in that expression wouldn't be the same value as this one here, but we don't know what they are at this point. So there's a couple, question 6 is rather similar to those. You can have a go. And question 7 looks at another pictorial way, or something that we're very familiar with, is our bar models. So if we take our bar, split, there's our whole. So if we had one bar here split into 3 very equal pieces, and each of these pieces was X, how could we show the length of this piece? Okay, X, X and X. I'm sure you got that one nice and quickly. Try this one. This is a bit more tricky. So in this one, we know that the whole length is A plus 6. So there. If I label that bit 6, you should be able to label this piece. And you should be able to tell me something about the length of the A, the size of the A compared to 6. So this must be A. But we know because we draw a bar model proportionally as accurate as we can, we know that A has to be around about twice the length of this piece here. So A must be around about 12. Okay, now this last one on here. What if I gave you this one, A plus 6, put my 6 here, but then split this one up into 4 pieces? So you know that this here is A. So how would you write each of these pieces here? Think back to how we talked about using fraction notation. Got that A and it's split into 4. Is that how you would do it? Yeah, so each of these would be A divided by 4. That is the end of the video part. If you go now and have a go at questions 6 and 7 and mark everything once you've finished. So those people who are doing this at home, this is very similar to what people will be doing in school today. So hope it makes as much sense when I'm talking to nobody on my board as it does when I'm talking to the class. See you soon. Bye.